morning all. Welcome you back to the lecture series of electrical wiring and safety. This is Jagdish, assistant professor from Department of Biomedical Engineering. We are discussing about the load calculation. As a quick brush up, we will move on to what we have studied in the last class. That is, what is electrical load, what are all those classifications, and what is connected load, and what is demand load, what is load factor, and how to calculate load factor. Then what is load profile, what is the use of this load profile, then what is demand factor and how to calculate the demand factor. In today's lesson we are going to have a small case study or a problem to make all the things what we have studied in the previous video to get used and apply it for having a small estimation of how this load is calculated in a residential building. So house electrical loads are, as of you see in the diagram, an air conditioner, a heater, a geyser, refrigerator, any external load connected to the socket, all are considered as an electrical load. So let's move on. If you have a drawing room of size 6 meter cross 4 meter, how the wiring has to be done or how the ventilation has to be done in terms of electrical part. What should be the luminescence or lighting we need, and how many numbers, and if numbers increase or decrease, how the load calculations or load drawn by those appliances will vary, etc. We'll discuss in this particular video. So here for a simple drawing room, the size of the room is 6 cross 6, and here we have a wiring diagram where we have electrical appliances shown in the line diagram. That is, we have T1, T2, T3 as fluorescent lamp, that is tube lights, and B1, B2, that is branch 1 and branch 2 represent a ceiling fan, and L represent the normal fluorescent lamp or a normal bulb, or it can be an LED light. So the dimensions of the room and the positions where the fluorescent light, LED light and the fan has to be placed is being given as a simple diagram. And you wonder how we fix these number of fluorescent light or these number of fans to be there in the drawing hall. Let's move on to the discussion. So with the simple diagram, we will also have a small wiring diagram where the phase and neutral, this is a single phase load connection, how the phase and neutral wire has to be connected and branched to one another effectively. So we will move on to this wire diagram later, and first we will understand how this calculation is being done. Suppose this drawing hall required an illumination of 100 lux, and we have to consider the depreciation factor and utilization factor to calculate the flux. That is, so 100 luminous into 6 into 4 divided by 0.5 into 0.6, that is 6 into 4 represent the values of the luminescence to be converted into lumen. So that is, we have to have 8000 lumens for the drawing hall. So how many light has to be provided to get that kind of luminescence is being calculated in the last 3 steps. That is, a tube light, that is a fluorescent light of 40 watts has to be required to have 6000 luminescence, and a lamp of 100 watts which is having 1700 luminescence can be also used. This is only for lighting purpose. So when you add 6360 plus 1750, we have 8000 luminescence, which is approximately the flux what we have calculated. So we need 3 tube lights and 1 lamp to get that luminescence in the drawing room. Now let's move on to the ventilation part. So this is an area of 6 meters into 4 meters, and this is a room which is not ventilated, and we are desired to have a fan of wing which is having a 48 inches in length. So if you calculate the space and if you calculate the area covered by the fan, that is 3.67 and 3.67, we approximately need around 2 number of fans to cover the entire space to get ventilated. So this is how we fix how many number of fans should be placed in the particular room. So for placing those sockets and controls, and the height of the switchboard has to be fixed 1.5 meters above the ground. So this is the common measurements what we required in order to install the applications inside the room. So now let's move on to the load calculations. So the simple load calculations here. First we have three tube lights, that is represented as commonly lamp. So 3 into 60 watts, it is equal to 180 watt totally, and fan 2 numbers into 60 watt, that is it is consuming around 120 watt, and we have a socket outlet with 5 amps, that is equal to 2 into 100 watts can be connected in the 5 amp socket. So it can contribute to 200 watt, and one fluorescent lamp which is having a wattage of 40 watts. So totally add all the power consumed by those connected loads, that is equal to 440 watts. So divided by 230, which is the single phase power supply or the voltage from the main line to the residential building. It is a single phase line, so we are taking it as 230. If it's a 3-phase line, we have to convert accordingly, or we have to take the number of 440 and different according to the phase what it is connected. So now when you divide 540 divided by 230, we have approximately the amount of load in terms of amps, that is 2.4 amps. So this is how we draw a simple line diagram, and we, according to the requirement of lighting and according to the requirement of ventilation, we calculate what is the number of appliances we need to have those to meet those requirements, and how these to be connected by wiring, and what is the load capacity it has to be taken from the main line, and how the wire thickness or the what gauge of wire has to be selected in order to connect all these appliances together has been discussed or designed like this. So I hope this video gave a small idea of how to draw a simple electrical wiring diagram and how to calculate the load requirements of a simple residential building. Thank you all for watching.